The conclusion that we talked about in our last video of the drill results at Crunchy Hill was that the gold mineralized zone we believe to lie at a greater depth than one would normally expect in a classic epithermal system. And the top of an epithermal is today's hot pools, steaming pools, or geyser systems. And these are so crucially important to us in exploration because these silica ledges that the geyser systems form are very resistant to erosion. So in our area, these things are 150 to 170 million years old, and they're still present with all these delicate textures, and they tell us where the original land surface was, and we know to go down from that level. In looking for a classic epithermal system as a model for our exploration, the best place to look is 100 kilometers down the road at Ruta del Norte, which is a classic epithermal system, and it was found by our chairman's former company, Aurania Resources. This is, the green is volcanic rock, and this is their discovery section. So they drilled borehole number 49 on a geophysical anomaly, a red blob in the geophysics that told them there was something here. They drilled it and they didn't hit much. They stepped across in a section and they drilled this borehole, which was a miss, but fundamentally important. Steve Leary, who was leading up the geological team, did absolutely spectacular work there because he recognized this center, which is where the geysers come to surface. It's a silica bar. And from the arsenic and stuff that he had hit there, he realized, or his team realized, that they were close to something. So although there was no gold in this 300-meter borehole, he knew that they were right there. And they stepped back and they hammered in this hole, which was truly spectacular, 240 meters at just over 4 grams. That was the discovery hole on Ruta del Norte, borehole number 51. What we've done here in looking for a classic epithermal deposit is just taken the Ruta del Norte situation and just taken the faults out to simplify it. The fluids that carry the gold and silver and other metals in an epithermal system comes off a magma at some sort of depth and rises along a fracture which has the silica precipitating in it or accumulating in it, and that forms a vein over time. But originally it was a fracture. So you have a fracture going to surface that's carrying all these fluids up to surface, and then it forms this sinter bar with the geysers and everything at the old land surface. The mineralizing fluid that comes off the magma that's going to give rise to the gold and silver deposit contains water and carbon dioxide and a little bit of salt. And any gold that it's carrying is complexed with hydrogen and sulfur. That's what makes the gold dissolve in that fluid. Same thing with the silver. Most of the silver is carried in the same sort of HS complex. And that fluid rises up the fracture until it reaches a point where it just starts to boil. And that's why altitude is so important in epithermal systems, because you're looking at the point where a fluid will boil, and that level would be the same here as in a fracture next door, as in a fracture next door. The gold is always going to start coming out of solution more or less at the same elevation below the old land surface. With our model at Crunchy Hill, we started to look for explanations as to why the epithermal system is developed there, but there doesn't seem to be any gold in it. And so mapping in the lower altitude areas around Crunchy Hill came up with the fact that at low altitude there are these sedimentary layers with lots of carbon, and they smell of diesel. They've got vestiges of oil left in them. So now what we're thinking is that the gold and silver that would have come off the magma in the fluid and in the fracture is rising up here It rises through this bed, picks up the methane from there, and the methane instantaneously makes the fluid boil, and that boiling drops the gold and most of the silver out of solution and makes it form a vein, a gold-silver vein deposit at greater depths than you would have in a classic situation represented by Ruta del Norte.